hopefully people know what linear geometry is. If not, that's perfectly fine. Linear geometry refers to straight lines, or a linear relation is a polynomial of degree 1. So what is a polynomial? A polynomial is when we have, like x to the power something, x to the power 2, x to the power 3, x to the power 4. A linear relation is just something that's x to the power 1. So, you've definitely seen this before. Anything in the form y is equal to mx plus c. And hopefully you have come across this before. You can see, that's to the power 1, right? That x there. So we say it's a polynomial of degree 1. The c tells us the y-intercept. The m tells us the gradient. And that's really all there is to know from this. All right. So now that we know, what is a linear line, well, what are some things we can do with the linear line? And one thing that's really nifty, and they do get you to do this in a lot of different questions, which can be annoying, is finding the distance between 2 points, right? So, given x1 here and x2 here and y1 and y2, how do I find the length of this line? I'll give you guys a bit of time to think about it. Maybe you guys can come to the solution yourself. Think a little bit about right squared or right angled triangles and how we can use that here. I'll give you guys maybe 30 seconds to have a think about that. Okie dokie. Well, hopefully you guys had to think about it. I think the best way to go about doing this, finding out how to do something, is to draw it out. Once you draw something out, it's really easy. Well, it makes it not really easy. It becomes a lot more easier to visualize things. You don't have to do everything in your head. That's another thing that's really important in maths. Don't be afraid to draw. You really want to draw out these scenarios because they give you really confusing scenarios, right? And you need to be able to like sort of piece together that information. Best way to do that, draw it. Alrighty. Let me see if I can get my pen out and we can try work this out. The reason I brought up a right angle triangle is because, well, we know Pythagoras theorem, right? A squared plus b squared is equal to c squared. And that's what we can sort of use here. So I'm going to make a line between these 2 points. Well, that's a really janky line. Assume that's a straight line. And then I'm going to make a line down this way here as well. Actually, I'll do it in a different color. And I'll do it in dots. Okay, cool. So now we have a right angle triangle here, right? Now, how do we find the lengths of these sides, right? How? Well, we can create a third point here. What's neat, right, about doing this is that we know the x coordinate of this point and we know the y coordinate of this point. So this point is just x2, comma, y1. Okay, cool. That's kind of nifty. Well, so how do we find the length of this line? If we're not changing, the height, and we're only changing our x position, to find the length of this line, we just need to subtract both the x coordinates. Ooh, wait, give me 1 sec. I think my laptop's about to die. That is not great. Yikes. All right, hopefully it's fine now. Okay, so as I was saying, since it's just the horizontal distance that's changing, what we can do is we can do x2 minus x1, and we'll find that distance here. So x2 minus x1. Cool. And we can do the same thing for the height. Since all that is changing is our height or our y position, what we can do here is subtract our y positions. So y2 minus y1. Okay, cool, right? Okay, and I'm going to call this side d, or distance. If you guys remember Pythagoras theorem, it's a squared plus b squared is equal to c squared, right? So I'm going to do x2 minus x1 squared plus y2 minus y1 squared is equal to d squared. Okay, and now it's our final step. We just need to solve for d, right? And the way we do that is we take the square root. So d is equal to, I'm just going to write this out again, x2 minus x1 squared plus y2 minus y1 squared. And the last step is we just take the square root of this. Cool, nice and easy, right? So that's actually our equation for the distance between 2 points. Yeah, sweet, cool. I think, yeah, I also had it already animated in here. So you guys can also see this again in your spare time with a cool animation in the middle as well. All right, so a couple notes on the distance formula. It's not on your formula sheet, so this is something that you will need to remember. And a good way to remember this is to just derive it using Pythagoras theorem like we did just then. If you do ever forget it, you can just really rederive it again, but ideally you would never forget it. And when you're substituting points, it doesn't matter, which one is x1 and y1, which one is x2 and y2. It's because you're finding the difference between x values and you're finding the difference between y values. So you're finding like the absolute difference, right? Like the difference between 5 and 0 is the same as the difference between -5 and 0, right? Just because, to go from 0 to -5, I need to travel -5 steps back. It doesn't make it too different from going from 0 to 5 because all you need to do is travel 5 steps forward. Like really, it's like the direction that has changed, if that makes sense. Sorry. Yeah, that's really it. Okay, so how do we go from here to find the midpoint between 2 points? Well, we know how to do the distance. Would the midpoint be the same? I'll let you guys have to think about that. Here's the formula anyways. Sorry. Here's the formula anyways. Have a think about why we can't just take the distance and then half it. I'll give you guys a couple seconds to think about that as well. Okay, all right. So if we go back to the distance formula, you'll see that it doesn't give us the coordinates. It only gives us the total length of this line, right? However, to find the midpoint, we want to find the coordinates. So what we're doing here is taking the average of the x1 and x2 points and the average of the y2 and the y1 points. That's all that's happening here. That's just an average formula. And so the average of 2 points, or if you're taking the average of two things, you should generally land in the middle of those two things. So that's what we really use here. So by taking the average of these two, we're landing in the middle of it. And like so with y2 and y1 as well. Okay, let's talk a little bit about the gradient. If you remember, the gradient is represented as m in y is equal to mx plus c. So the gradient is usually referred to as rise of a run. Why, right? Why would it be rise of a run? I'll get to that in a little bit. And so that's one way people remember it, rise of a run. I like to think about it as change in y divided by the change in x, and that's just y2 minus y1 divided by x2 minus x1. Once you guys get to calculus, this statement might make a little bit more sense. That's why I like it a bit more, just because it's very descriptive of what calculus is. Okay. I'll let you guys have a crack at this. I'll give you guys about 30 seconds to do this. So have a go. And yeah. And don't be hesitant to draw it out if you need to. Okay, hopefully that was enough time. All right. Um, so our very first step is to substitute in what we want to say as x1 and y1. Again, this is arbitrary. It doesn't matter which one you set to be the ones and which one you set to be the twos. In this case, I've decided to set 3 as x1 and 2 as y1. So I just plug everything in, subtract everything. You'll notice that everything is happening in steps. And this is not just only to show you guys, you know, what every single step is, but it also helps me like know, like when I did my actual exam, this is how I did it. Some of you might be like, oh, you can just skip from this to -1, but I found it more helpful for me to take it step by step. It prevented me from making really silly mistakes. Like, sometimes I could do 1 minus 3 is -4 or something really dumb like that. So yeah, this really helped me prevent silly mistakes in the long run. So yeah, you can use this to find the gradient between any 2 points. And so that's why, we get that equation. So any 2 points that lie on, the same line will have the same gradient. Okay. Um, if we do this in a different order, we get the same values, right? So, we label this as the ones and we label this as the twos. We'll still get the same values. It doesn't matter what order you do it in, as long as your twos and ones are consistent. As long as it's always 2 minus 1, it's fine. Okay. So why is it rise over run? Well, this is our linear line, right? This is x1, y1. This is x2, y2. Oh, well, I guess this one is x1, y1, x2, y2. I'll get out my pen. So x1, y1. Sorry about the really bad handwriting. I'm drawing on a mouse pad, so x2, y2. Okay, cool. Um, Now we can, again, like before with the distance, we know that this point here, oh, that's not a minus, by the way, that's a comma. This point here, we know that this is going to be same x coordinate as x2, same y coordinate as y1. So really, the distance between this point here and this point here is just going to be x2 minus x1 and y2 minus y1. Okay, so now you guys can see rise over run is just y2 minus y1 divided by x2 minus x1. Another cool thing to note is that since we can form this triangle, we can also use tan. If you guys remember, tan is opposite over adjacent. And that gives us tan theta is equal to rise over run. So if we have a linear line, right? This is a common question type, by the way. If we have a line like this, and we want to know what this angle here is, but we can find the gradient, equate it to tan theta, and then do arctan theta. So arctan is just like inverse tan of the gradient. And that will give us, our answer there. All right. Have a go at doing this. I think the polls aren't working, but have a think, and I'll reveal the answer in a little bit. Alrighty. Okay, this is a bit of a throwback. Hopefully you guys remember some stuff from last year, maybe, if you were taught it. All right, so what is not a method for finding the x-intercept of a quadratic? Um, well, the quadratic formula, by definition, will tell us the x-intercepts. Completing the square is a form of factorization, which can lead to solving the x-intercepts. And null factor law is also how we figure out x-intercepts. If these terms aren't familiar to you, don't worry, we'll go through them soon. But the one way to not do it is to convert it to expanded form. It's really difficult from doing that. Um, so try not to ever do that. So if that's the only, like, if you don't understand what, the rest of these are, at least take this away with you. So then in the next couple slides, we can get into, how to do the rest. So then, you know the right way of finding the x-intercepts.